All right, guys, I wanted to take some time to explain this z-score table a little bit better. If you don't master the z-score table, it's not the worst thing in the world. They're not going to give you this table on the Common Core exam, but I want you to be able to use it because this is why z-scores are useful. We don't just want to find z-scores for the sake of finding them. We want to look at how likely it is that something will fall in that range. So what we would do is we would use this table to figure that out. Now, this is a very real world applicable thing that is done often. One big thing is when babies are born, they'll get all of their information about how big the baby is, weight wise, height wise, how big their head size is, and they'll tell you exactly what percentile you are in as a baby compared to every other baby that's born on average. So they'll use this table or a table just like it to figure out what percentile each of those measurements are. So for instance, if you've ever been told by your parents that you were in the 95th percentile of height as a baby, what that means is that the doctors used this table. They figured out how tall you were. They figured out what that z-score would be compared to the mean height of all babies. So they found a 95 on this list, which would be right around here somewhere. There's a 95. 95 would be here. We would use this. And so your z-score must have been a 1.65 if you were in the 95th percentile. That could mean any height compared to what mean they used, but this would be the z-score that you got for your height. And what that means literally is, if we look up here, I'm just going to use this as a visual. If your z-score was 1.6 and it ended up being here, let's say 1.6, what do we say, 5? Whatever it was, if your z-score is 1.65, that means that there's you and all the people ahead of you, or behind you rather, were shorter when you were born. So you are in the 95th percentile, meaning that all of these people make up 95% of all of the babies born. So you are a very tall baby because you were taller than 95% of all the other babies. So you can use this table to help you find all that data that you need to find. If you're given a score and another score to go with it, let's say you're given a score of 26, depending on what's going on, and a score of 28. And you do your conversion. Remember, we have to do our conversion that the z-score equals whatever your number is minus the mean all over the standard deviation. And you do your conversion, and you find that your z-scores end up being 1.02 for 2.6 and 1.1 for 28. And the question is, what percent of the data lies in that range? Well, what you need to do is figure out where those are here. So 1.02 is right here, and 1.1 is right here. So let's take this back up to our bell curve. If you're one standard deviation above the mean, and that's right here, we'll say. This is at your 1.02. There's your 1.02. How much of the data is less than that number? Well, 0.8461, so 84.6% of the data is down here. So this is 84.6% of the data because it's less than that. But then we also have the score of 1.1 on the nose, so that's here. And why don't we use blue for that? That's right there. And we know that the amount of data that's less than that is 0.8643. So that's 86.4% of the data in here. And that's all of this, all of that. But what we want to know is what percent of the data is right in here if I want to find the probability of someone being in that range. So in order to find that, I can take my 86.4, which includes this range here, and just subtract from it the 84.6, and that'll give me this sliver of data. So if I do 86.4 minus 84.6, I should get 1.8. And I'll write it in black so we can actually see it, which means 1.8% of the data falls in that range. So if I were to ask the question, how likely is it that I will pick a person who is between a 26 and a 28? Maybe this is age, maybe, I don't know, who, whatever this is. How likely is it? Well, the likelihood of that happening is 1.8% because 1.8% of the people fall between these two z-scores. That's how you use this table, and that's how you'll use it on the homework from Wednesday night. All right, and I'll do some examples on the homework too, but this should be a crash course in how to use this thing, okay? I hope it's helpful. I'll do some examples from the homework as well.